Hello students, welcome to the world of chemistry. This is Dr. Vikram Panchal. I am dealing with thermodynamics of chemistry and this is lecture number 22. In this lecture, I will explain you numericals based on first law of thermodynamics. Okay, so let us start with the first one. Find out delta E, Q and W if 2 moles of hydrogen at 3 atmospheric pressure expand isothermally at 50 degrees Celsius and reversibly to a pressure 1 atmosphere. So in this numerical you are given number of moles, two pressures are given. P1 is equal to 3 atmosphere, P2 is equal to 1 atmosphere, temperature is given 50 degrees Celsius plus 273, it will be around 323 Kelvin. Okay, this much is given. Now we have to find out delta E isothermally. The process is isothermal process. For isothermal process, delta T will be 0. That means there is no change in temperature. There is no change in temperature. So absolute temperature remain constant. Okay. So temperature remains constant for ideal gas, and for ideal gas internal energy change depends only on its temperature change. So for an ideal gas, undergoing isothermal process, internal energy change will be 0. So delta E will be, or delta U will be 0. So for isothermal process, if delta E is equal to 0, then delta E is equal to Q minus W. And if it is 0, then we can say that heat exchange is equal to work done. Now as it is a reversible process, for reversible process, the formula to find out work is W is equal to minus 2.303 nRT log, as two different pressures are given, so we can use log P1 upon P2. So in this equation, we will put values of all minus 2.303, number of moles 2, R is a gas constant. If you take 1.987 into 323 log 3 upon 1, then your answer will be in calorie, or minus 2.303 into 2 into 4.184 into 323 log 3 by 1, that is log 3. This will be in joule. So you can find out work either in calorie or joule. and this is the answer. So you have to find out answer by yourself. Next numerical, 1 gram of water at 373 Kelvin is converted into steam at the same temperature. The volume of water becomes 1671 milliliter on boiling. Calculate the change in the internal energy of the system if the heat of vaporization is 540 calorie per gram. Even this is given change in different units, that 1 liter atmosphere is equal to 101.2 joule, and 1 calorie is equal to joule upon 4.184, or 1 joule is equal to 4.184 calorie. So this way we can change it. Okay. So answer of this question would be W is equal to P delta V. You are given two different volumes. Okay. So, and here pressure is given 1 atmosphere. Volume should be in liter. So it is 1671 ml, which is equal to 1.61671 liter. So W will be 1 into 1.671 liter atmosphere. This can be converted into joule, that is 1.671 multiplied by 101.2. The answer will be in joule. Okay. Next is Q. Q is given 540 calorie per gram. This is given to you. Now, this joule can be converted into calorie. So 1.671 into 101.2 upon 4.184, this will become calorie. Okay. So delta E is equal to now Q minus W. So Q is 540 and this is W, that is 1.671 into 101.2 upon 4.184. The answer will be in calorie. So this way you can find out final answer by yourself. So next numerical, a gas contained in a cylinder fitted with a frictionless piston expands against a constant external pressure of 1 atmosphere from a volume of 5 liter to a volume of 10 liter. In doing so, it absorbs 400 joule thermal energy from its surrounding. So determine delta E. Now W is equal to, P into V2 minus V1. Okay. So that is pressure is 1 atmosphere, V2 is 10 liter, V1 is 5 liters, so it is 5 liter atmosphere. If you convert this into joule, then W is equal to 5 into 101.2 joule. Okay. Then you can find out delta E. So delta E is equal to Q minus W. Q is given. Now, you found out Q, that is 400 joule, and W is 5 into 101.2. This will be in joule and the answer will be negative. Okay. So I think this is enough in this lecture. Thank you so much.